because, yeah. You can divide by x, and maybe it makes it a little bit, divide the top by x and divide the bottom by x. This is technically. And then this tends to infinity, and this tends, as x gets.
1 over infinity is 0, and 3 over infinity is also 0. So
Yeah.
it's 4 over.
So it's just 4. That's why it's 4. Yeah.
Okay,
So you
wow.
can simplify.
Okay.
So this, evaluate this, it's 4. Okay. That's the first question. Let's have a look at the second question. Not a wonderful start, but I kind of knew you would be tripped up by that one. You'd overthink it. Let's see, can we do basic differentiation? So there's 3 different derivatives here. Can you get the 3 derivatives? They are all the chain rule, of course. So multiply down by the derivative of this would be multiply down by the 5 to get 5x squared minus 3x stays the same. In the bracket, we'll deal with that in a second. Subtract 1 from the power. Then multiply by the derivative of what's inside the bracket. So you get 2x minus 3. I would tidy this up and multiply these two together. 10x minus 15. X squared minus 3x to the power of 4. This one is also, they're all the chain rule. So a quick rewrite might help here. 3x squared plus 3 to the power of negative 3 is another way of writing the same function. So its derivative then multiplied down by minus 3 times 3 gives minus 9. X squared plus 3 to the, subtract 1 from the power, that gives minus 4. And then multiply by the derivative of the inside now, which is 2x. Tidy that up a little bit. I multiplied this times this again to give minus 18x, and put this back down as a positive power, the power of 4 like that. And the last one, we can rewrite this straight away as x squared minus 3x to the power of a half. Then we can go about our chain rule. So the derivative is then 1/2 x squared minus 3x to the power of negative a half. Subtract 1 from the power. Yes, subtract 1 from a half. Gives 2x minus 3. Tidy this up then. I have 2x minus 3 above the line. In the denominator then, this comes down and becomes positive square root, but in the denominator now of this. Hopefully that all makes sense. All right, let's have a little look at question 3. Okay, let's look at it now.
Where like you have the 2 equations, but I don't know how to prove it other than the fact that it just works out in my head.
I'll show you. I think it's just logical. Okay, so the first thing I did was get the derivatives, just make sure we can do that. So this is still sticking on chain rule, I think, for now. What's the derivative of this? It'll be a, so the derivative of what's up here, and this stays the same. Yeah, so you multiply this by derivative, you can multiply after or before, but before is probably easier, just looks nicer. And 2x is the derivative of x.
ax plus 2x would be a plus 2 1. It just have to be.
Yeah. Yes. So, right, now we have to sub in 2 into both of them, and we know that it equals each other. So if I sub in 2 into this, I'm going to say e to the 2a plus 2 plus 2 squared is equal to ae to the 2a plus this one with 2 subbed in, plus 2 times 2. So we get e 2a plus 2 plus 4 is equal to the same on this side, except for there's an a in front. So the 4's cancel, and well, the only multiplier of this that would make these equal is a is 1. You could bring it over the same side and factor it out.
You bring it over the same side and just say equals 1.
Yeah, you factor out a minus 1 and then use the null factor law to finish that one. Okay, let's look at the next one, if I can remember where I put the freeze button. Okay, let's look at question 4. No, no need to double derive it. Okay, so how do we get the gradient of any tangent? So whatever the function is, we derive it, and then we can get the gradient at any one particular point, can't we? So we need to derive it, and then this is my point, so it'll give me the gradient at that point. So derivative, if you like, you could write this like this, and maybe that makes more sense as a chain rule again. So f dash x is 4 cos x to the power of 3 times the derivative of cosine x, which is minus sine x. At this stage, we can just start thinking about subbing in x to be 3 pi over 4. So f at 3 pi over 4. So we need to remember then also our unit circle here. I'll get to that in a second. Okay, so 3 pi over 4, that is 3 pi over 4 here, yeah? It's 135 degrees maybe? So it's around here. Cosine is...
Let's just cos 3 pi.
Huh?
Because the 4, you just times it in. Can't you just get rid of the 4 on the bottom of cos 3 pi?
No, you can't. No, you can't. No, you cannot. This is cosine of an angle. Okay, so let's get the cosine of the angle first, then cube it, and then do things in the correct order. Simplify the brackets first. Okay, what's cosine 3 pi over 4? Okay, so our reference angle is pi over 4, which is root 2 over 2 in general. Cosine will be negative in this quadrant, yes, so I have negative root 2 over 2 cubed, and sine in this quadrant is positive, isn't it? But we've minus root 2 over 2 here because this has a minus in front of it. So I know my answer is going to be positive because when that's cubed and that's cubed, that's a minus, and that's times a minus. So my answer is going to be positive. So I can kind of ignore the minuses for now. I'm just going to work out what this is. So it's 4 times root 2 divided by 2 times 2. So 2 times 2 fits into that once. And what's... oh no, I didn't cube the... Oops. I forgot it has to be cubed. That makes it different. Root 2 cubed is root 8, isn't it? So that's 4 times root 8 over 8. That's that first one. Times root 2 over 2.
Isn't it 2 by root 2? Root 2 times root 2 is 2, times root 2 is 2.
Oh, root 8 is 2 root 2, yes. Yeah. So root 8 is 2 root 2, as you said. So that's 8 root 2 over 8, if you want to do that. Times root 2 over 2, which we haven't done yet. The 8s would cancel, that's nice. And now we have root 2 times root 2, which is 2 over 2, which is 1. Okay, let's look at question 5. All right, so looking at our reciprocal functions for trig now. The derivative of this, you'll probably go to your formula booklet just to make sure. I think you can probably just do it in one step, yeah? From the formula booklet, I think it says this, yeah? But don't forget to multiply by 5. You haven't derived the 5x yet. So you put the 5 in front, perhaps. Don't forget to multiply by the 5.
Oh, okay.
Yeah, because you haven't done this bit. You've only derived the sec bit. Is it product rule? No, it's a special rule for sec, yeah. Oh. This one then, perhaps a rewrite with the power of a half might help to start. So this is a chain rule again. So y then is equal to a half cot x to the power of minus a half. Now what's the derivative of cot x? Refer to your formula booklet if you're not entirely sure. That's cosec squared x. Isn't it? Yes, it is. Okay, and some sort of tidy up of this might be in order. You can have the minus cosec squared x on top, and 2 root cot x on the bottom. You can put this as times root tan x if you want, but I think it's okay like that. Okay, so they're just straight from your formula booklet, use them. All right, let's look at our old friend L'Hopital, which you told me you've done. Can you remember what it does? First of all, is it possible? Is it one of the cases? Can you remember?
It's x squared.
ln x over x is just 1.
ln x.
1 over x.
No, because it's one of those cases where we're not quite sure. It's one of the ambiguous cases. The numerator tends to infinity and the denominator tends to infinity, so we're not sure is there a limit or not. So look, if you look, I put these in because I knew you'd forget. If we've one of these where we're not, it's this case. What do? We derive the top and the bottom and look at the limits of the derivative, don't we? Okay, C, can you, for limits? Well, we didn't do it in the first example. Yeah. Okay, so we determined that we can use L'Hopital's rule. So we look at the limit of the derivatives. So this one and this one. You probably didn't write this line, but that's what we're doing. So yeah, so the derivative of the top is 1 over x. Derivative of the bottom is 2x plus x. Now what you probably didn't do and what you might need to do here is tidy up this line. Because if I still use, maybe not 2x, 2x plus 1. Sorry, 2x plus 1, yeah. So tidy up this line so we don't have a fraction here because that's not going to work out again. So if how do I tidy up this line? How do I? You can just multiply the denominator by x here, like you're dividing fractions or whatever. Keep, change, flip, or similar. Okay, so what we're actually looking at then is 1 over 2x squared plus x, which gives an answer. So when I apply the limit to infinity, it's 1 over something really small, which is going towards 0. Or 1 over something really big, which is, which is going towards 0. Okay, tricky one there maybe if you forgot L'Hopital's rule. Let's look at question 7. All right, so we figured out we got to derive everything individually, kind of. The way we should write it is derive everything with respect to x. So we write it like this. It's a bit clunky, but this is what you would write. Perhaps you just went straight to the product rule. I think that's okay, though. Our product rule for this bit. It's a bit of a pointless line. You're deriving everything with respect to x, so you can just go ahead and do it. So we start off here. This is going to give 2x in it. The tricky bit is this bit, I suppose, because you mostly recognize that as the product rule. So how would I apply that product rule? Then it would be the first to the second plus the derivative of the other one. So I think y squared is the easy one. When I do y squared by the derivative of x, which is just 1, plus x times the derivative. Oh, what do I write then for the derivative of y squared?
2y dy dx.
Yeah, 2y dy dx, yeah. Okay, what's the derivative of y with respect to dx? Well, that's just dy dx. And the derivative of 21 is nothing. Okay, what's my idea next? Yeah, so yeah, it's like you're solving for dy dx or letting dy dx equal. All right, let's get rid of this bracket. So I have 2x minus y squared minus 2xy dy dx plus another dy dx here is equal to 0. Anything that's not dy dx, I'm going to move over here. Anything with dy dx, I'm going to factor out dy dx. I'm going to say that's 1 minus 2xy. See, I factored out the 2xy and the 1 here. and that equals y squared, minus 2x on the other side. So I factored out dy dx from both those, and then my final bit is divide by this bit. And that's it. Any questions there? Might be again.
I just wrote to the product rule for x, y.
Okay.
I just differentiated those ones from x squared.
Okay, let's check the next one. Yeah. All right, let's remember how to derive first of all. So to find the exact coordinates, stationary points, you're talking where the gradient is 0, aren't we? So that's where the derivative is equal to 0. So let's get that derivative, let it equal to 0. So product rule here. Oh, first, so we can do 1 times e to the negative x, the first by the derivative, the second by the derivative first, or whatever, plus, I confused myself by not writing it down, 1.
That's VU, not VU.
I know, I did it the wrong way around. Let's do that again. The first by the derivative of the second is going to be e to the negative x times minus 1, isn't it?
Yeah.
So I'm going to put the minus in front. Plus the second by the derivative of the first is going to be just e to the minus x, yes? Okay, so let that equal to 0. Let's have a little solve with that. Minus x e to the negative x plus e to the negative x is equal to 0. No, I can just factor out e to the negative x here, and I'm left with negative x plus 1 is equal to 0. And then from my null factor law, I think this gives x as 1. X as 1. I think this is always greater than 0, so it won't equal 0 at any stage, so that's a non-answer. So I'll just leave that out. So we have x is equal to 1. What do we do with that? Well, find the exact coordinate for a start. I only know one part of it, so finding the y value is a good idea. So y is equal to 1e to the minus 1, which is 1 over e. So my point is 1 and 1 over e. Now, the nature of the stationary point I need to know if it's a maximum or a minimum. How do I find that?
Double derive it.
The line thing? You can double derive it, or you can just look at your sign diagram. I'm looking at 1 here. What I really want to know is it going uphill or downhill before 1 and after 1? So maybe we can just look at the slope, or just take an example slope before 1. Let's put in minus 2 in here. What happens?
Minus 2e minus 2 plus.
Is it positive or negative? It's definitely positive, because that turns positive, and that adding a positive to that. So it's definitely positive before that. It's going uphill before that. And I think if you sub in a negative, it's going downhill after that. Or not a negative, a number value greater than 1. So if you sub in 10, that's going to give negative 10 here. And that's going to take over, so it's negative after that. So if it goes to uphill before it and downhill after it, it's what? A maximum, yeah. So it's a maximum.
For the double derivative, if it's more than 0, it's minimum, less than 0, it's maximum. You double